Okay. So an equal volume of water is poured into tank A and B. The base area of tank A is 4.7, the base area of tank B. The difference in the water level is 9 centimeter. Find the water level of tank A. Okay. Now, looking at question 3 and question 1 and 2. Question 3, you can't do quantity value table. But the storyline is about the same, right? Actually, not really, but seems like the same, right? But I may tell you what's the difference between question 1, 2 and versus question 3. Question 3, the data provided is very scant, means very little. Whereas you look at question 1 and 2, they provide you a lot of data. They give you length, breadth, and height. They give you, which is pretty essential, right? But if you look at question 3, they didn't even give you a base area. They give you the relationship of the base area and the difference. This is one difference. Second difference is this, right? They didn't give you the water level in the end. But if you look at question 1 and 2, they give water level in the end. So this, because there's so lack of data in question 3, the best method to approach this kind of question is using ratio. This is not just for question 3, okay? Not just for this, by all problem sums. If you notice, the question given to you has very little data, but give you a lot of fraction relationship. Use ratio, okay? Because ratio will help you to create more data. Let me explain to you. So they give you the base area of tank A is 4.7 base area of tank B, meaning 4 refers to A, 7 denominator refers to B. Okay, so you do this. Now, given that the equal volume water, meaning the water in both tanks is the same. If the both tanks is the same, okay, two tanks, one, there are two different base area. B has a bigger base area, A has a smaller base area. But if they both receive the same amount of water, then I will expect the volume, the height of the water in A must be more than the height of the water in B. The water level in A must be higher than that of B if they both have the equal amounts of water, right? So if 4.7, then the opposite, the ratio of the height will be opposite, 7:4. One way to check is this. Volume is base area times height, right? Correct. Volume is base area times height, right? Length times breadth times height. So base area times height. So you multiply. 4 times 7 is 28. 28. 7 times 4 is 28. So both, when multiply, they are equal. So when volume of water is the same, the base area ratio and the height ratio are inversely proportionate. So it's opposite. Now, what information you have here is not that you haven't used is a value that you haven't used is 9 centimeter. And 9 centimeter refers to the difference in water levels. So we are talking about the difference here, not here, okay? We are talking about difference here. Don't use the wrong ratio, although they look the same. 7 minus 4 is 9 centimeter. So 3 units is 9 centimeter, 1 unit is 3 centimeter. Find the water level of tank A times water level is here. Don't times this. This is water level. So 3 times 7, 21. Got it? I don't know how you get 12. You go 3 times 4 or 3 times 4. Please, you must use the right ratio. We are talking about the water level. So use this ratio. You get 12 means you multiply the wrong ratio. Okay, let me explain question 4. So equal volume of water, okay, the keyword again, equal volume. So remember, like question 3, when you have the same volume of water, your base area ratio is opposite to your height ratio. So the bigger, the broader, the bigger the base, the lower the water level. The smaller the base, you expect the higher water level if both the container have the same volume of water. Okay. tank A, the water level of tank A is 5/8 the water level of tank B. So height A to B is 5:8. Base area will be opposite. 5. Okay. Double check. 5 times 8 is 40. 8 times 5 is 40. So base area times height is volume. So equal volume. You see the word highlighted here. Keyword, huh? Now, 900 square centimeter refers to the difference in their base area. So focus on this ratio, not this one, this ratio. Pick the right ratio, base area. Difference is 8 minus 5 units. 3 units is equal to 900. 1 unit is equal to 300. What is the base area of tank A? Focus. This is the ratio we are talking about, not this one. Huh? We are looking for tank A. So this is the number. This is the value, tank A. 8 times 300. Answer is 2,400. Okay. How did you even get 562.5? Such a strange number. So let's do this. So volume water in container X is 310 the volume of water in container Y. So X to Y is 3:10. If both containers have the same base area. Now, when two containers having the same base area, for the purpose of primary 5, when two containers having the same base area, essentially the question is telling you it's the same containers. Okay, the two containers is the same, identical. So that's for P5. All right. So same base area meaning they are the same container. So if there's two similar container, one with the ratio of their volume is 3:10, then I will expect, being the same container, the height has to be 3:10 as well. All right. Same container. If volume, this one got 310 the volume of Y, then the height got to 310 the height of Y. Huh? Make sense? Now, let's continue. Keyword, same base area. 21 centimeter more. So 21 centimeter is the difference in the water level between Y and X. So focus. This is the ratio we should be working on. Okay, this is the ratio, height. So 10 minus 3, 7 units is equal to 21 centimeter. 1 unit is equal to 3 centimeter. Read the question. What is the water level in container X? So we talk about water level again. Focus. This is the ratio, not this is the ratio. So 3 times 3. 9 centimeter. How did you get 10? 30. You must have multiplied 10 here. That means your ratio must flip. You must have accidentally flipped your ratio. Right? Take note, same base area, meaning the volume ratio and height ratio must be the same. Okay? Manan got it? Now let's look at question number 6. Answer to question 6, everybody. Okay. Bottle A and bottle B have the same base area. Bottle A contains 3,000 ml water and bottle B is empty. How much water must be poured from bottle A into bottle B so that the water level in bottle B is 2/3 of bottle A? Okay. Very similar to question 1 and 2, but you can't do the quantity value table because you do not have basically the data in this question is very scant. All right. So let's continue with this. So in the end, we know that the water level of B to A is 2:3, right? 2 for B, 3 for A. And if they're the same base area, essentially they are the same container, then the one with the then the volume and the height ratio will be identical. Okay. More water, the greater the height. Less water, the lower the height. Okay. Now, 3,000 ml. 3,000 ml refers to the water in container, it refers to all the water, actually, refers to all the water, because bottle A contains 3,000 ml and B is empty. So if B is empty, meaning that the entire of these 2 units and 3 units must be coming from bottle A, which is 3,000 ml. So 2 plus 3 units is all the water. So 1 unit or 5 units is all the water. 1 unit is equal to 600. Any question up to this point? If you have used 3,000, 3 units is equal to 3,000, then you didn't read the question carefully. Somebody must have used 3 units to 3,000. Okay, it is 5 units is equal to 3,000 because B is empty. All the water came from A. So all these 2 units and 3 units all came from A at first. This is what happens in the end, 2 and 3. But originally, everything comes from A. So A is 2 plus 3, 5 units. So what you need is 600. What's the question? How much water must be poured from bottle A to bottle B? So in the end, you pour 2 units into bottle B. So 2 units times 600. That's the answer. Okay? Any question?